3. How to allow branches to recouple. Replace the Markovian dissipator by a memory kernel. A minimal, still linear modification that can restore coherence is to give the environment memory, non-Markovian dynamics. Replace the simple differential Lindblad equation by an integro-differential equation with a memory kernel. The time derivative of rho 01 of t, that is, how the off-diagonal element of the density matrix changes with time, is equal to minus e times omega times rho 01 of t, minus the integral from time 0 to time t of the following product. The memory kernel, written as k of t minus t prime, multiplied by rho 01 of t prime, and then integrated over t prime. Meaning in plain language, this equation says that the rate of change of the system's coherence, rho 01, comes from two contributions. 1. A coherent oscillation term, represented by minus I omega rho 01 of t, which just describes rotation in phase space at frequency omega. A memory or decay term given by the integral. This term means that the present evolution depends not only on the current time, but also on the entire history of the system, weighted by the kernel function k. In other words, it describes non-Markovian decoherence, where past interactions continue to influence the present. The integral from 0 to t represents how the environment's past influence continues to affect the system. The function k of t minus t prime is called the memory kernel. It measures how strongly the environment remembers interactions that happened at earlier times t prime. The product k times rho 01 of t prime means that what happens now depends on what the system's coherence was at all earlier times, weighted by how much memory the environment retains.